In this activity, we'll use the LabQuest 2 and the PhotoGate to determine the initial velocity in part 2 of the activity and the acceleration. Then we will use that information to predict how far the car will run at that initial velocity in a time of 0.3 seconds. So you can see what the setup is. This will already be set up for you. You'll need to pick your car. You need to make sure your car runs straight. You'll find you have the little slot here that most of the cars, if you line them up on the slot, they will go straight. But you need to double check. Some of the cars won't do that. So you get a car that goes straight. Then the next thing we need to do is we need to figure out how long the car is. Because this is just like the lab where we use the ball bearing. We need to know the length of, in the ball bearing case, it was the diameter of the ball bearing. We need to know how long the car is. Specifically, we need to know how long the part of the car is that will break the beam in the PhotoGate. So as you can see right here, this is unblocked. So what you want to do is you want to push your car forward until it says blocked, and then you put a mark right on the back side, or you can do the front side, right where it blocks, goes from block to unblock. Then you slide it on down, and you put a mark. You find where it goes from block to unblocked, and you put a mark there. Then you measure the distance from one mark to the other, which I obviously didn't do, but you'll need to measure that distance, and that will be the length that you put inside your PhotoGate. Just a reminder, your timing, yours may say motion, you need to make sure the timing's on gate. Make sure the timing's on gate, and then the length of the object is whatever length it is that you measured. And we'll stop with the stop button. Once you've done that, this is set. Pick a distance above the PhotoGate. Doesn't matter how far it is, just use the same distance every time. Once you set up put the correct values in, you put your gate in and your length in, then you're going to run your car through 5 times. So you hit the play button, and if you have data, you can discard it. And it doesn't matter where you start, just so you start the same place every time. And I run it through 5 times. So 1, 2, 3. I'm not being careful about starting the same time because this guy doesn't count. 4 and 5. Then you hit stop. You notice I had the graph. I've already chosen the graph to be on show graph, just graph number 2. So I go to analyze, I go to statistics, I go to velocity, and my mean is 0.521, and that's the velocity. That is, if I start at this point, that's going to be the initial velocity if I start counting from right here. So from that information, you should be able to compute the acceleration. Then I want you to predict and calculate how far this car will go after it goes through the gate in 0.3 seconds. You predict that, you find what that measurement is, then you put a mark, put a piece of tape, wherever it is, and then I'll start at the same spot, and I'll take my video physics and I'll let it run, and I will see how accurate I am. Then I'll determine the percentage difference between my measured time and my calculated time.